In this video, we're going to discuss about completing the square method. So completing the square method is used to change the function, quadratic function, from the general form to vertex form. This method or this vertex form is very useful when we want to sketch later on. But let's have a focus on how to do the completing the square, how this method works. We have two cases here when a equal 1, positive 1, and when a is not equal to positive 1. What will happen? What is a here? A is the same a from the general form. Yeah, and the form in the vertex form, if a equal 1, we're going to get x plus p and close bracket square. You see the square will be outside of the bracket plus q. And if the a is not equal to positive 1, what will happen? A will be factorized out here. And x plus p square plus q. But remember, p on the left side and the p on the right side isn't the same. This is just some kind of like variable we're going to use. But the a in here and a positive 1, a not positive 1, it's the same with the general form. Okay, let's start with the a equal 1. Okay, so what happened? If we have x squared plus 8x plus 1, okay, I'm going to write the fx function here. So that will be the first step, open bracket. Okay, so that will be square there. X squared will only be x, and plus 8 there will be 8 divided by 2. Alright, so this is some kind of like method or rules. Minus the 8 divided by 2 just now and square that value. And plus 1. Where do we get plus 1? So the plus 1 is the last part here. We bring it down. So what happened next? If the value in the bracket, because this value is square, so we can't do much about it. So that is square minus 16. 4 square 16 plus 1. So it must be minus 16 plus 1. Therefore, that will be x plus 4 square minus 15. This is our vertex form. Okay, and if you want to check, right, what will happen? So let's expand this so we can do this quickly. So this will be x squared plus 8x plus 16 minus 15, yeah? So that will be x squared plus 8x plus 1, see? So we get exact same like this one. So this is just changing the form. So we're not changing the values or we're not reducing any value. So we just change the form. And again, it will be useful for sketching graph. Alright, next I'm going to show an example when a is in positive 1. Okay, so let's say fx equal 2x squared plus 8x plus 2. So we're going to do about the same method, but we have to make the a here positive 1. Okay, and how to make that positive 1? By factorizing it. Imagine each of it will be divided by 2. So what happened inside? X squared, 8 divided by 2, that will be 4x here, plus 1. Okay, so we can quickly check. If we expand this, 2 times x to x squared, to 4, 8 to 1 to, okay, so it means that our factorization is correct. So next step, we're going to do completing the square like what we did on the left side here. Okay, so we're going to open to bracket and it will be square. So x squared will be x, plus here will still be plus, 4 will divide by 2. So, and if you can do it mentally, you can straight away write 2. So I just want to show what happened. If I skip, you may confuse. Plus 1, and this is in this bracket. So the 2 will be outside here still. So let's simplify this. X plus 2 square. And this is 2 square minus 4 plus 1. Right? 2 square is 4. So that will be 2. And that will be x plus 2 square minus 3. Okay. And now we're going to put back the 2 inside. However, this bracket have square. We can't put 2 in the bracket. The most we can do is put outside, right in front of it. So that will be 2x plus 2 square. And 2 multiplied by negative 3 at the back, that will be negative 6. Okay, so you can check. If we expand, we will get back the function earlier. So you see here, the last part, what we got, our vertex form is similar with the vertex form up here. Okay, and alright, so you want to check? Okay, let's check this quickly. Okay, 2x squared plus 4x plus 4. Okay, and then minus 6. This will be 2x squared plus 8x plus 8 minus 6. You can see at the back here it's already positive 2, right? So that will be exact same, or it means that our vertex form is correct. Okay.